So hello guys, welcome to this video. In this video I'm going to be going over how to make a self-defined or a user-defined vector class template. So basically there are some prerequisites for this video. You need to know some basic C++, you need to know how classes work, you need to know how constructors, destructors work, you need to know about modifier access list, you need to know about operator overloading because we're going to be using it. I'm going to be using it over here, operator overloading, and you need to basically and very obviously you need to know what vectors are, right? You cannot make vectors without knowing what vectors themselves are. So you need to know these things, and there are like millions of resources on the internet. You can look it up on Google, on YouTube, and it would hardly take you half an hour or maybe an hour if you're starting from absolute scratch. You need to know these things. You need to know how pointers work also. And yeah, after you have all that knowledge, you are all set to watch this video. So basically what we are going to do is we are going to make our own vector class, the implementation of our own vector class, and these are the things which we are going to implement. We need to have an initializer function which would be our constructor. We need to have these modifiers: push, pop, delete, flush, and shrink. Shrink over here is synonymous to the normal shrink which we have in shrink to fit, which we have in C++. Flush basically deletes the entire, makes the vector empty, and push, pop, delete have the obvious meanings. We need to write logic for square brackets operator, which basically means, let's say we have a vector. We are using a vector with a capital V to not get confused with a vector with small v. That would be illegal anyways because that is a keyword. But yeah, we are using a vector with a capital V, and let's say we define it like this, and it has some value in it. So we want to see what's on the 0th index of this vector v1. So we could write something like this, but since this v1 is of vector, and whenever I say vector from now, it would mean vector with a capital V, basically what we are, the class which we are writing. So v1 is of vector type, and that vector is not defined. Like every logic for this class or for objects of this class, we need to code it basically. So we need to write a logic for this also to access the 0th element or the ith element. And then we have display. I basically want to have three displays: the normal display, which basically displays the entire vector list; the v display, which basically is an acronym for verbose display, which would also print along with the vector contents. It would also print the size and capacity of the vector; and the address display, which basically displays the address of each of the vector elements. Very importantly, you need to know what is the difference between size and capacity of a vector. It's very important. And then we have these four functions basically, which gives us the information about the vectors: the size, the capacity, is it full, is it empty. And then we have iterators. If you know what vectors normally in C++ are, you would know what I'm talking about. Basically, begin would give us a pointer to the first element in the vector which we have created, and end would give us whatever is next to the last element in the vector, and last is a function which I want to add, which would give us a pointer to the last element of the vector. So we have all these things ready, and I have also have a vector.cpp program ready with some boilerplate code to save some time. And yes, I'm going to be using Notepad. So yeah, so let's start with first the vector class. So it's going to be a template so that we can initialize it with any data type, whether it be int or float or double or string or character. So first of all, we write template and type name. I like to call it data type, and then the class name would be vector. So first of all, we define our private variables, and there would be three private variables. The first would be int v size, which basically means vector size, then vector capacity, and then we need to have a pointer. That's the way we're going to be accessing the vector. So the pointer is going to be of whatever data type which is supplied to us during runtime. So that would be data type pointer, and we'll call it data. So let's go to our public section now, and let's define our constructors. So basically I just also wanted to get one thing sorted. Let's say we are initializing a vector like this v1. What this would essentially do is it would create a vector which has a capacity equal to 0, right? And and what this would do is this would create a vector which has a capacity equal to 4, and in both the cases the size, since the vector is empty, the size would be equal to 0. That's what I want to implement with the constructor over here. So the default value would, let's say we get the value in initialize capacity, and the default value would be 0, and then we initialize v size to 0, and we initialize v capacity to initialize capacity, and then we just write a constructor code, which basically means we would use the new keyword and we would allocate whatever the initial capacity is. We would allocate that amount of data in the memory, and that address would be stored in our data over here. So we write the code for that, which is data is equal to new data type, and the size would be equal to v capacity. So this is our vector constructor. Now let's define a deconstructor. Deconstructor in this case is very necessary because we are allocating memory in the heap using the new keyword, and we need to obviously free that memory. And to do that, it's very easy. We just simply delete the data. One important thing over here is data is like a vector, but like we are using the new keyword with an array. So over here we also need to give square brackets. Let's say we were just writing like data is equal to new int. We could have just deleted like this, but since we are defining an array of a specific size, we need to use this. So this is our deconstructor. So now we have done the initialization part. So now we need to add the modifier, the push, pop, and delete. So push would first the push function. The push function would obviously be a void function, right? So push, and it takes whatever the data type is, let's say, and calls it as x, maybe, I don't know, and we just push it to our vector. So we the way we are going to be using a vector is accessing a vector while we are coding it is using data and then whatever the position we want to access it to. So it's the first data, like initially the size is equal to 0, so the data x should go into the 0th position. So we could just write v size, because that would work, and then we could initialize that to x, and then we need to also increment. Now that we have data in this, we also need to increment v size. So we can do this like this, but another way of doing this, and another very clean way of doing this, or a very clever way of doing this, would be using the postfix operator. So we just say v size plus plus. Basically what happens is, let's say v size is equal to 0 over here. So after this in this segment, basically v size is still equal to 0, but the next time, let's say I see out v size over here, this would give me 1. If it was prior to this call it was 0, it would give me 1. So it does both the job. It maintains that index while incrementing, such that the next call the value of v size would be incremented. So that's how we push data. Now let's just delete data. Another thing I wanted to clear out is the difference between pop and delete. Delete would just delete the last data, while pop would also return as the copy. So basically, whatever the conventional standards are, the conventional meanings of these terms, we are going to be implementing that. So delete, again, we are going to be deleting the last element. So the last element would be over here. Let's say we appended one. We pushed one element into our vector. So the size would be now equal to 1, but the index would be equal to 0. So we need the size should the index which we want to delete, the last index, would be 1 less than the size. So one way of doing it would be v size minus 1. We basically delete. We want to delete this. So the way we delete this, basically we just decrease the size, so we have no access to it, right? So we just do v size minus minus. So basically, let's say there was a vector 2, 5, and the size was, let's say the vector was 3, 5, and the size was 2. Now basically we just shrink the size, so now it's 1. Even though the 5 is still there, we don't have access to it. So for us, or for the program, it would look like the vector is now this. That is how delete basically works. Very, very simple. I'll just write it like this to make it more concise. This is our delete code, and this is our push code. We got our push and delete ready. Let's add pop. Pop would return whatever the data type is of the vector that we have initialized. So data type pop, and it would basically return data, and again it would return the last index is basically v size -1, so we could do v size -1, but then we have to decrement it. So basically what we could do is, instead of doing that, we could use prefix. Over here we used postfix, but over here we could use prefix, so we could do v minus v size, and yeah, that would be it. It would return us the data while decrementing the size. It would return us the last data, and it would also delete the last element. And by deleting, basically we don't have access to the last element now. So we have our push, del, and pop functions ready. So I'll just save it and I'll just get it off my checklist. And let's just try and run the program for once. So let's just first compile it and see everything is working. Yes. So let's say vector, it's an integer vector, let's say v1, right, and I defined it with the capacity of 5, and let's say v1 dot push, and let's push 10 to it. Let's push 10 to it, and of course it's working, but the thing is we haven't defined any functions to display the data, right? So let's do that, and then we'll check whether it's working properly or not, right? So over here we have 3 definitions of display. We're going to implement, and very quickly we just need to implement this, and we just need to switch a couple of things for vDisplay and aDisplay. So let's write the void display function first, which basically is going to display our vector. So cout vector, and one second, yes, cout vector, and then we do a for loop for int I is equal to 0 while I is less than v size. This is just a standard code. It's just like arrays over here. We just need to print the elements of the arrays. It's very synonymous. So we just print data I, and we also add a bit space to it to make it look nicer and make it look readable. You cannot read it if the data stick together. And over here we just cout an end line. So actually we could just display the vector right now. So display, and let's just push some more data into it. Let's push 7, and let's push 28, and let's push 141. So let's run the code. Should be working. There you go. 10, 7, 28, 141. Right. Now let's implement our aDisplay and vDisplay. Let's first implement the vDisplay. vDisplay just basically means verbose display. Verbose display, we are going to also print the capacity of our vector, which would be v capacity and end line, and then size of our vector, which would be v size. So let's do a vDisplay over here. Let's actually do let's do an end line first, and let's do a display and a vDisplay so that we can see the difference, even though it's very obvious. But this is our display and this is our vDisplay. So the vDisplay is obviously more informative, but if we just want, and we can actually remove this, we don't need this every time. So yeah, so if you actually want just the data, I'll just run it again. So if you want just the data, this would work, and if you want more information about the vector itself, you can use verbose display. That's basically what verbose means. And just let's write code for aDisplay. aDisplay, we are just going to be printing the address. So we could just do and a over here and aDisplay, and a over here, and we could just write vector address. So let's also do v1 dot aDisplay. There you go. These are basically the address of our vectors, though add this where this 10 is stored is this 141 is stored at this address. So this is also very useful maybe. So we have got this sorted also. So now let's check the functionality of the pop and delete function, right? So let's just not use these things. We're going to be using verbose display, and we display it. Let's do v1.delete. Let's do it a couple of times, and we do a display right after it. So let's see what the output is. So the capacity was 5, size was 4, and this was a vector. Since we deleted the last two elements, the size is 2, while the vector is 10 and 7. So 28 and 141 is deleted as expected. And let's do a pop, right? So let's say int x is equal to v1.delete, and also over here we could print popped data, and we could print the value of x. Let's see if it's working. So okay, not v1.delete, I'm sorry, it's v1.pop, right? Because delete is a void function. This should work. Yeah, of course the spacing is necessary, but 1 second. So yes, the vector was this, and we deleted one and we popped one data. 141 was deleted prior, so we're deleting 141 over here. Let's just remove this also so it makes more sense. So this was a vector, we popped 141, and now the capacity remains the same. The size was 4, and now it's 3, and the vector is such. So we have successfully implemented these functionalities, and now let's just write these basic functions, basically the size, capacity, and a couple of boolean functions indicating whether the vector is full or empty. So let's just get rid of this. And another very important thing which I should have mentioned over here is while we are pushing the data, we could also, I'll write it over here, we need to probably the most important function is the reserve function. So basically when the size of the vector and the capacity of the vector is equal, basically the vector is full and we want to push more data into it, we need to reserve more data. That is, we need to make the vector bigger, right? So we need to add that function. That's probably the most important function, which I unfortunately didn't mention over here. So I apologize for that, but we have to write this also. But for now, let's write these four basic functions. So we have our int size, which would just simply return the v size. Then we have our int capacity, which would also return the v capacity. By the way, the code for it would be mentioned in my GitHub repository. I'll give a link to my GitHub account in the description box below. You can check it out. I've also done a lot of more projects, so you can also check it out. So yeah, coming back to the code, in capacity, then we have a boolean function. I'll write the boolean function separately. So the boolean empty, basically it would return whether v size is equal to 0. So it returns 1 if it's true, 0 if it's false, and a boolean full, which basically again would return whether v size is equal to v capacity. So yeah, this is it. So you can test it. Let's just test let's say the empty function, or let's test the full function, because over here if I run this code again, okay, there is a simple error somewhere and it's over here. So that's sorted. So the size is 4 but the capacity is 5, so the vector is not full. So we could just do v1.full, and this should give us a negative, which is 0, and it does not because we are not printing it. So is the vector full? And this should do it. Is the vector full? 0. That means the vector is not full. So let's add another data to it. v1.push, let's say 65, and this should give us 1. The vector is now full because the size is equal to the capacity now. And yeah, you could also on yourself on your computer you could try out the other functions, the what was the function, the empty function, the size, the capacity. It is not as fun actually, so I'm not going to be covering that, like trying every function. So anyways, we have got this sorted. Now we need to write code for the operator, but we also need to write a code for the reserve function, which is probably the most important function. So let's first write the code for the reserve function, then we'll go to the operator, then flush, shrink, and then at the end we'll go to the iterators. So reserve function, right? So I'll just get rid of this and just make it a little bit less crowded. Yeah. So basically, uh, where is the push function? Here is the push function, right? I need to write it properly because I need to write more code over here. So we only do this if there is size, right? Of course. I mean, I assume you know what a reserve function is because you know what vectors are. So basically, if v size is equal to v capacity, that means the vector is full, we need to reserve some more space, right? And how are we going to do that? We're going to let's just define a prototype somewhere. I'll come back to this later. Let's first define a bit of a prototype. So over here, let's just define define it at the top. So over here, we just define a reserve function. Basically, it would be a void function, a little bit of a space, void reserve, and it's going to be taking an integer that would be our new capacity. What's the spelling? Capacity. Okay. So, and we will write a code over here. So basically, we need to supply this with our capacity. Oh, it's over here. It's more easy. So reserve. So we reserve the new capacity should be equal to v capacity into 2. But the issue over here is, let's say if I initialize the vector as such, vector int v1, I don't supply any capacity, so the capacity would be equal to 0. So if we append any data to it, if we push any data to it, first this check would be executed, and v size, which is obviously equal to 0, which would then equate to v capacity, which is also equal to 0 because we haven't initialized any capacity to the vector while initializing it. So the reserve would get v capacity into 2, which basically means 0 into 2, which would always be equal to 0. So a smart way to do, like, get over this is basically add a 1 to it, right? So it would be 1, and the next time it is called, it would be 1 into 2 plus 1, which would be 3. The next time would be 3 into 2 plus 1, which would be 7, if I'm not wrong. So this is how we do it, reserve v capacity into 2 plus 1. So this would be a reserve function, the reserve function call, and now we define our new capacity over here, right? So first of all, we need to make a copy of what we need to do is we need the data, which was our original pointer, to be pointing to this space where new capacity is allocated, while we also need another pointer which we will call old data, which would hold the previous basically the previous vector, and after the allocation is done and using the new capacity, we would basically copy the data from the old data to the new data. So it's easier typed than explained. So basically, data type, we need another pointer to data type, and we called it old data, which would be pointing to where our data is pointing, and now data would be equal to new data type, and the space would be equal to new capacity, right? And now we basically have this data thing is our data basically, which was our driver pointer, which was basically pointing to our vector, is now pointing to this new space, which is allocated with the new capacity. So hence, to have access to the previous vector, we are using old data, so we have a copy of it, right? Now basically what we need to do is we need to copy the data from old data to new data. or data, not new data, data. So we just use a simple for loop for int I is equal to 0 and I should be less than v size and I plus plus. So basically data I should be equal to old data I, and after the copying is done, just write copying the data from the old to the new pointer or the new vector. After this is done, we could just delete the previous vector. So this would reserve space for the vector, and I'll just check the brackets once. Yep, working. So this should work. So let's see. So let's say we have this code, right? And there is obviously a semicolon error, which would be over here. So let's run it again. Okay, so now the capacity is 5, size is 3, right? Let's say we add a couple of more things. Let's say we add the same data. Why does it matter? We could add any data. So the capacity is 5, size is 5. So now if we add more data, let's say v1 dot push, let's say we add 78. So this should call the reserve function, and we would see a change in the capacity if everything works properly. And the capacity, yeah, it's working, but we didn't update the capacity, right? Because the capacity is still the same. If you go back to our reserve function, which should be up here, yeah. So the V capacity is still equal to what it was previously. So we need to make it equal to new capacity. So V capacity should be in camel case. V capacity is equal to new capacity, and this should work. There you go. So the capacity was 5, so 5 into 2 is equal to 10, 10 plus 1 is equal to 11. So this is working. So let's try to add a bunch of more data. Let's see what happens. And let's do another display. And there you go. So the capacity was 11 to, and once the vector was full, we call the reserve function, which basically reserved this vector with 11 into 2 plus 1, which basically means 22 plus 1, 23. So our reserve function, which was our main function, is also working. I'll just clear this clutter. Also this. Also, another thing we could do is let's initialize this with nothing. Let's just try to print this. So yeah, size 0, capacity size 0 and vector is empty, and let's try to add some data. Let's say 7 is my favorite number, so let's add that, and let's print the vector again. So there you go. The capacity is now 1, so that's why we added the plus 1 over here, right? Because if we reserved using into 2, basically the 0 into 2 would be equal to 0, the capacity would still be 0. So now it's 1. Let's add a bunch of more 7s now. Let's see what happens, and it's working. There you go, it's working. So we have got our reserve function ready, and now we need to write basically the flush and the shrink function, and then we'll write the code for operator logic or square bracket operator logic. So let's write code for shrink and flush functions. So basically, I think I explained this before, but flush would delete the entire array, or not the entire vector. So the vector would be empty, and shrink would make the vector more space optimized. Like if the capacity is, I'll show it to you here. And so the capacity is 15, size is 9, this is our vector. So the shrink function would just make the capacity and the size equal. The capacity would be equal to 9 then. It's similar to shrink to fit in C++. So that's what we are going to do. So first, we need to write code for our shrink function, right? So the shrink function would be again a void function. So void shrink. Basically what we need to do is we need to first of all check whether the v capacity is greater than the v size or not. So if v capacity is greater than v size, so that means there are some space which are have not been allocated any data, so we need to shrink it. So what we could do is basically we could just reserve, and we could just reserve whatever the v size is basically. So this basically makes a new vector with this in which the capacity is equal to the v size itself, because remember if we check the reserve function, this parameter was the capacity, the new capacity parameter, and while calling the function the argument we are passing is the size. So basically this new vector would have the same size and the same capacity. So the shrink function is as simple as this. We have to do nothing. So let's just run the code again. I don't know why I deleted the push things. I need to write it again. 1 second. So push, let's add a couple of datas, not a couple, a bunch of datas. So let's add 2 more, and then let's just delete one verbose display. Yes, so the capacity is 15, size is 8. We want to optimize this vector, like we want to store it more efficiently. So v1 dot shrink, and then if we do v1 dot display, verbose display, I'm sorry. So there you go, capacity is now equal to 8. And now let's say if we add another data to it, it would call the reserve function and the capacity would then be doubled. So let's add 12 to it and do another verbose display. So there you go, 8 into 2 16 plus 1 17, because the vector was full. So our shrink function is now working. So I'll just get rid of this, and let's just make this 12. Let's add a bunch of unique numbers. Looks a little bit more better. 57, and let's add 42, and that would be enough. So just running this for one. Yeah, so it's working. So now we need to write the shrink function is done. We need to write the flush function basically. So what the flush function would do is that it would delete the elements, the number of elements there are, right? So the number of elements are basically, there are v size number of elements, so we could just essentially run a I'm sorry, my neck's dry, I've been speaking for so long. So we could essentially run a for loop, and we could run it, we could initialize it from 0, and we could run it the number of basically v size number of times. This is how we do it. So just some generic C++ looping, and we just delete it. So, and there is one thing which we haven't done over here, and that let's see if you can spot it basically. So once we let's call the flush function v1 dot flush, and we again display it. So there you go. Okay, there is something which is not working. I is equal to 0, I is, oh, there you go. It's there are two things which we didn't consider. The second one I'll get into later, but the first thing which even I didn't expect is basically when we are deleting, the v size itself is getting changed, right? Because we are deleting and the v size is getting decremented. So we need to have a counter basically. So let's say int counter, which basically stores the value of v size, and then we can just use the counter, and this should be working. There you go. And now what I was talking about is our vector is flush, the size is 0, but the capacity is still 7. So to make it more optimized, we could, after we have deleted this, we could just call the shrink function So there you go. Now the capacity and size both are 0. So now we have this 2 working. So now we just need to do a couple of things and we'll wrap this video up. The first would be to write operator overloading code for square brackets. And this is a very interesting thing basically. So what we want to do is, let's just clear this clutter again. Okay, and this is our vector, right? Let's say we want to write, this is a vector v1. Let's say we want to know what's at the 0th position. So we need to write logic for this basically. Using the square brackets and the ith index, we need to write logic for that. So the way we do it in C++ is using operator overloading. So basically our return type would be data type, because we are going to be returning a data type, because when we, let's say v1 0, we want to receive whatever is at the 0th index, so we'll receive 12, which is an integer, so we are receiving a data type. So data type and then operator, and we also get an index basically. So I hope you know what operator overloading is, because I'm not going to go in much depth about it, but this is basically what it is. If you need to write operator overloading code, this is the basic syntax: the return type, the operator, and then whatever operator you want to work with, and then basically this will be the arguments. So now we need to do a sanity check over here, basically, that if we only return the data if the index is valid. So the index cannot be less than 0, and the index cannot be greater than or equal to v size. So it should not be less than, the index should not be less than 0, and the index should not be greater than or equal to v size. Then only we return whatever the data is. So we basically return data at the index which is specified, and this should work, right? So let's just compile the code for once, and let's just see out v1, and let's say what's at the 0th index. It's 12, and let's say at the 3rd index basically it's 57, so it's working now. So we could also basically, and very obviously, we could also initialize it to a variable and then print out the variable itself. There you go, 57. So this is how basically we would implement this. So our operator overloading is also working. We can now access data in our vectors using the square brackets operator, and now we basically need to add iterators for begin, end, and last. So if you know vectors in C++, you will know what these are, right? Begin is the address of the first element. Last is basically, I don't think last is defined in C++, but I want to define it anyways. Basically this would give us the address of the last data or the last element in our vector, and end would be whatever is adjacent to the last. So end and begin are defined in C++, last isn't, but we want to define it anyways. So let's just write the code. Basically what this would return is, let's write the code for begin first of all. Now what begin would give us back is basically a pointer, right? And that would be a data type pointer. So data type pointer begin, and this would just return us, first of all we need to check whether the size is not empty. The size shouldn't be empty, but I think all the error checkings can be done by anyone, so the error checkings are not going to cover in this video. So we could just essentially write begin, and this would return us the address of whatever is in the 0th index, right? And same for, or we could just essentially do this. Instead of doing this would just give us the data. This is basically the first index. Or let's do it more specifically, it would, or even this would work. So it would give us the pointer which is pointing to the first element. And let's add code for end or what was it called? It was called last. Okay, last. So last, basically we need data. We need to get the address of whatever is the last element. And how do we do this? Basically, let's say data is pointing to the 0th index. Data plus 1 would point to the first index, right? Let's talk about position. It would be more clear. Data is pointing to the first position. Data plus 1 would point to the second position. So we could do is basically v size, but this would give us whatever's at the next of n to it, right? Let's assume there is a vector 2, 3 and 5. The size of this vector is 3, and data, the return data would give the address of this would be data plus 1, data plus 2. This is the last element, and this is data plus 2. Data plus 3, the size. So data plus size would give us whatever is here. We don't know what is there, but it would give us the address of whatever is next to the last element. So over here, instead of data plus v size, we had data plus v size minus 1. This would work for our cause. But in the end function, it would give us a pointer to whatever is next to the vector. So I think these things are working. So let's just do an A display. This would make things a bit much more clear. So this is a vector basically, and we could do cout. This is the first address, and then we could do v1 dot begin and end line, and cout this. This is the last address, v1 dot end, and a last cout. This is the address adjacent to the last address, and this this wouldn't be end, this would be last. And this is the address adjacent to the last address, and that would be v1 dot end. So let's just run this and see what's happening. So first address, these are the address, and the first address is this, the last address is this, and this is the address adjacent to the last address. Basically this is what we use when we are using iterators. I mean, basically like generic C++ vectors, this is what we use, the end iterator. So I'll do that also. Let's say we don't want to use display, we want to use the iterators to basically display what the data is. So we could do for int star pointer is equal to v1 dot begin, right? That was the function name, right? Begin, and the terminating condition should be v1 should not be equal to, the pointer should not be equal to v1 dot end, and we just increment the pointer every time, and then we just cout, and over here we could just cout vector, and over here we just cout, we dereference the pointer basically and add a space to it. So this should print the vector. We could just also let's do a display to confirm it. So there you go, it's working. So the begin, end and last thing is also working. So I think we are done with this video. I don't think I had anything else planned for this video. Alright, I'll just see. So this was the code basically, right? So yeah, let's just do one final run. So let's make a simple vector, and let's do v1 dot a display, v1 dot v display, and it's not working for some reason. v1 dot v display, verbose display, it should work. Okay, so 1 second. there seems to be some issue. So let's do v1 dot push, or let's do 2. Okay, now it's printing, but it was printing before. Like, let's do display. Okay, there is something wrong with the verbose display. Oh no, now it's working. I don't know why it wasn't working before, but yeah. So we have this. So let's v1 dot push, and let's do 23, and let's push 27 and 141. Let's put push 7. Let's push 58, and let's do another v1 dot v display. So there you go, it's working. The capacity is 7, size is 5. Let's just copy view display, and let's just shrink the vector and display it again. So the vector is shrunk now. Let's flush the vector, v1 dot flush, and the vector should be flushed now. So yeah, I think that's it for the video. This is also a very basic implementation. You can add a lot of things. Basically, you can add insert function, basically inserting at a specific position. Let's say insert number comma position. Basically it would insert a number at a certain position in the vector. You could do it. That would require shifting the vector, and it's not that hard. It's basically it is laborious. You can do it. It would require some effort, but I don't think it's interesting because you learn no new concepts out of it. But you could do it. You could do that. You could add delete functionality. Basically it would delete not the delete which we have implemented. It always deletes whatever is at the end. You could also delete from the beginning or from the ith position if it's valid. So you could add that. You could also add you could also add operator overloading. Like we defined operator overloading over here for square brackets. Let's say you could do something like this. You could do void operator, and you could overload the tilt operator. I think it's called tilt. I don't know what's this called, but tilt operator basically. And what this would do is this would code to reverse the vector. You could do essentially whatever you want basically. So let's say if the vector is 1 2 3, if I write tilt v1, it should give me 3 to 1. So it's very cool, right? This is basically your data type, so you could add or remove whatever you want. So you could do it. It's very interesting. You could play around with the code, but for this video I think this would be enough. So thanks for watching, guys, and if you found this video informative, consider subscribing my channel and liking this. If you have any doubts regarding anything of this code or any other thing which you might want to ask from my previous videos also, you could just comment in the comment box and I'll try to reply as soon as possible. And if you have any ideas of what videos I could make in the future, because I'm running out of ideas, you could also comment in the videos. So yeah, thanks for watching. Consider subscribing my channel, and the code for this video would be in my GitHub, which would be linked in the description box. Thank you. Bye.